Alright, boys and girls, welcome back. I'm going to change it up a little bit. Let's try something new. I'm going to start with something funny here. And it says, what do you call a security guard who works at Samsung? Alright, you ready? Guardians of the Galaxy? Get it, Galaxy? Alright, well that's enough of that. Let's go ahead and jump into today's lesson. We are on Module 2, Topic B, Lesson 5. And our objective is to connect visual models and the distributive property to partial products of the standard algorithm without renaming. Alright, so let's take a look at this. So 1 says, draw an area model, then solve using the standard algorithm. Use arrows to match the partial products from the area model to the partial products of the algorithm. So we're going to go ahead and solve for our first problem A here. It says 24 times 21. So when we're setting it up on our area model, we said we're always going to take that first factor. In this case, our first factor is 24. So we're going to take that 24 and put it up top, but we're going to decompose it into each place value unit. So we're going to say that it's 2 tens, or 20, plus 4 ones, or 4. Now we're going to do the same thing for our second factor here, but what we're going to do is we're going to decompose this on the left side here. Now we said the 20, or the 2 tens, has more value than the 1 1. So the 20 is going to drop down. It's almost like we dropped it in a fish tank and it's heavier than the 1. And then we have our 1 up top. Now, because we have a 2-digit by 2-digit, we know we're going to have 4 problems that we need to solve. So I'm going to go ahead and put some lines in here. Set up our vertical line first. Then we're going to have a horizontal line going across, right from the plus sign, straight across our box. So you can see my area model right there. Now I have 1 times 4 ones is 4. Then I have 1 times 20. Well, we know that that's 20, but if we didn't know what it was, we could have just looked at our basic fact and said 1 times 2 is 2, times 10 is 20, or 2 tens. Alright, let's look at the bottom here. We have 4 times 20. So we say, well, 4 times 2 is 8. And then 1 0 is times 10. So that's going to be 8 tens. Then we have 2 tens times 2 tens. 2 times 2, our basic fact, is 4. Then we say, well, 1 0 in this factor, 1 0 in this factor. So that's going to be 2 zeros. So it's 400. So keep that in mind. Now we're going to add our partial products going from left to right. So we have 20 plus 4. Hopefully you said 24. Then we have 400 plus 80. Hopefully you said 480. Now to find our total of both our partial products, we have to add them up. 4 ones, 10 tens, which is equal to 100. 100 plus 4 is 500. So let's see. We should get, for our total here, we should get, for when we do our area model, our standard algorithm, we should get 504. Let's take a look. So in my area model, I'm going to use the distributive property to distribute my 1 to this 4, and then I'm going to distribute my 1 to this 2, which is really 2 tens, because it's 2 in the tens place. So let's go ahead. 1 times 4 is 4. 1 times 2 tens is 2 tens. So that's how I get my 24. Similar to here, 24. And it says use an arrow. Let's use a better arrow than that. We can see that our partial products match up here. Alright. Now I'm going to distribute my 2 tens in my second factor. The 21 is made of 2 tens. So 2 tens to my 4 ones, and then 2 tens to my 2 tens up here. So 2 tens times 4 ones. Well, we know that 2 tens times 4 ones would be if every person had, 4 people had $20. So that would be 80, or 8 tens. That's why we have to put this 0 in here. We're done with our ones place. Now this is 2 tens times 4. So 2 tens times 4 is going to be 8 tens. Now we have 2 tens times 2 tens. We know that's going to be 4 in the hundreds place, so 400. All right. As we can see, our partial products once again matches up. All right, now we have to do our addition. 4 ones plus 0 ones equals 4 ones. 8 tens plus 2 tens equals 10 tens, which I'm going to rename as 100. Then 100 plus 400 is 500. And as you can see, my partial products match up. 24 for my top, 480 for my bottom, and my total product is 504. All right, let's take a look at 1B here. So now we have 242, which is a 3-digit number, times 21, which is a 2-digit number. So I'm going to need 6 boxes or 6 multiplication problems to solve this. Let's go ahead and look at it. My first number I come to, or my first factor, is 242. Factored out each place value unit. My second factor is 21. All right, then I'm just going to go to my plus signs and draw my lines. We'll do our horizontal line first this time. And now I'm going to do my vertical lines right underneath my plus signs. And you see my 6 boxes, my 6 multiplication problems I'm going to have to do. Let's go ahead and solve some problems. I'll do this top one in green this time. So we have 1 times 2, 1 times 2 ones. And then we have 1 times 4 tens. So 1 times 4 is 4, and then it's times 10 because I have 0. Same thing. 1 times 200 is going to be 200, or we just say our basic facts. 1 times 2 is 2, plus my 2 zeros. Moving down to my second factor here. Excuse me, my second digit in my second factor. So I have 2 tens times 2 ones. Well, I know 2 times 2 is 4, and I have 1 0, so that's going to be 4 tens. 2 tens times 4 tens is going to be 2 times 4, which is 8. Then I have 1, 2 zeros, so it's going to be 800. Last but not least, I have 2 tens times 200. 2 times 2 is 4. Count my zeros. 1, 2, 3. It's going to be 4,000. All right. So let's add up for our partial product here. Should have did that second number in red. Voila. Magic. All right. So now we have 4,000 plus 800 plus 4 tens or 40 for the bottom. And up top, we're going to do this first. We have 200 plus 40 plus 2. So we know we're going to have, let's move that over some so we can get our thousands placed in. 242. I added all of these 3 partial products up in green. And now for my red, I have 4,840. So when I add these up, I get 2 ones, 8 tens, 10 hundreds, which is equal to 1,000. 1,000 plus 4,000 is 5,000. All right, let's see if that is correct when we do our standard algorithm. See how our partial products match up. So now we have 1 times this whole number. We know 1 times anything is going to be the opposite number. So 1 times 242 is 2, 4 tens, and 2 hundreds. So 242. Now, I'm going to multiply my 2 by each one of these. Now remember, this 2 isn't just a 2. It's a 20. It's 2 tens. So keep that in mind as we do this. So I have 20, or 2 tens, times 2 ones. Same thing here. 2 tens times 2 ones. That gives me 40, or 4 tenths. Now I have 2 tens times 4 tens. 2 tens times 4 tens is going to give you 800. My 8 goes in my hundreds place. Now last but not least, I have 2 tens times 2 hundreds. That's going to be 4,000. My 4 goes in my thousands place. And once again, that should have been red. And there we go. So now let's add our partial products up a second time. Even though we see we had the same numbers, it should come up with the same thing. So we had 2 ones, 8 tens, 10 hundreds, or 1,000. 1,000 plus 4,000 is 5,000. So as you can see, all of my partial products match up, or both of my partial products match up, as well as my total product. Which in this case was 5,082. All right, let's take a look at 2 here. 2, it says solve using the standard algorithm. So we're going to use the standard algorithm. We're not going to use the area model. We're just going to jump straight to standard algorithm. Let's take a look here. So I have 314 times 22. Well, I know that if I can solve these 3 problems, 2 times 4, 2 times 1, and 2 times 3. So if I know the answer to those 3 problems, then I'm just going to write it down here. If I know what 2 times 4 is equal to 8, 2 times 1 is equal to 2, and 2 times 3 is equal to 6. If I can solve those 3 problems, I can solve this using standard algorithm. Let's see how. So my first 2, I'm going to say 2 times 4. 2 ones times 4 ones. That's going to be 8 ones. Now I have 2 times 1 10. That's going to be 2 tens. Then I have 2 times 3 hundreds. That's going to be 6 hundreds. All right, now I'm on to my second factor. I'm going to distribute this second factor to my 4, to my 1, and to my 3. So let's go ahead and take a look here. Make this second one, we'll make it blue. So I have 2 tens times 4. That's going to be 8 tens. Similar to this, it's just in the tens place. Now I have 2 tens times 1 10. Well, tens times tens, we know that's going to be hundreds. It's going to be 2 hundreds. Similar to this, just in the hundreds place. And then I have 2 tens times 3 hundreds. I know that's going to be thousands. Hundreds times thousands. Excuse me, 100 times tens is thousands. So that's going to be 6 in the thousands place. Let's go ahead and add them up. 8 ones, 10 tens, which is equivalent or equal to 100. I'm going to regroup my 1. And I have 6 hundreds plus 2 hundreds plus 100 is 9 hundreds and 6,000. All right, so we have 6,908 for our final answer. All right, next is 413 times 22. Same thing. If you notice, the digits changed places. So my 4 went from my ones place to my hundreds place. My 3 went from my hundreds place to my ones place. So still the same 3 factors here. Excuse me, the same 3 multiplication problems to solve this standard algorithm. Let's look. So I know 2 times 3 is 6. 2 ones times 3 ones is 6 ones. Now 1 times 2 in this case is 2, but here is 110 times 2. So that's going to be 2 tens. Then I have 4 hundreds times 2 ones. It's going to be 8 hundreds. On to the second factor, I'll change that back up. Now I have 2 tens times 3. Well, that's going to be 6 tens. and I have 2 tens times 1 10 is going to be 2 hundredths. 2 tens times 4 hundredths is going to be 8,000. So I know some of you may say, well, why is he saying the place value unit after he says each number? Many of us learn, self-included, just to multiply this way, and I'll show you on C. But the way that we learned is just to do the multiplication problem like you're multiplying by the actual digit itself. And that's okay, but I'm trying to get you to really understand why each digit is in the place value unit that it is in. So let's go ahead and add this. 6 plus 0, 6. 2 tens plus 6 tens is 8 in the tens place. 8 hundredths plus 200 is 10 hundredths, or 1,000. I have my 1,000 plus 8,000 is 9,000. So my answer here is 9,086. All right, so I just made a reference to how we learn, or I learned multiplication. Most of the parents that are watching probably learn multiplication this way, where you just say 2 times 3, 6, 2 times 1, 2, 2 times 2, 4. Now remember, this is a 4, but it's not 4 as in 4 ones. It's 4 in the hundreds place. So in order to understand how this 4 got to the hundred place, I want you to recognize that this 2 is 200. And if I multiply 200 by 2, I get double. I get 400. So that's why that 4 is in the hundreds place there. All right, so keep that in mind when I'm saying the actual place value units. All right, let's take a look at this second factor. And I'm going to walk through it the way that, just continue the same way I'm doing here. So I have 3 times 3. Most people make a mistake here and say 3 times 3 is 9. But remember, this 3 is not a 3. It's 3, but it's in the tens place. So that makes it 30, or 3 tens. So if I had 3 tens, I would have 30, 60, 90. That's why I have to put this 9 in the tens place. I annex my 0, put my 0 in there. All right, keep that in mind. 3 tens times 3 is 30. 3 tens times 10, or 110, would be 300. And then I have 3 tens times 200 is 6,000. All right, so now we're going to add those up. 6 ones, 9 plus 2 is 11 tens, or 110. Regroup 10 of my tens as 100. Now I have 400 plus 300 plus 1 is 800. Then I have 6,000. So I have 6,816. All right, looking at number 3 here. Let's get rid of this down here. And it says a young snake measures 23 hundredths meters long. During the course of his lifetime, he will grow to be 13 times his current length. What will the length be when he is fully grown, or full grown? Let's go ahead and take a look here. So I know I'm doing the same thing. The only thing different now is that I have a decimal. It's not quite a whole. So I'm going to break it down the same way. I'll put my place value chart. I know that I have, that's a place value chart. I'm going to put my area model. So I have 2 tenths plus 3 hundredths for my first number. And then my second number is going to be my 13. 13 is equivalent to 10 plus 3. Let's go ahead and draw our lines in for our area model. Draw my vertical line first. Then I'll draw my horizontal line, side to side, straight for my plus signs. All right. So we're going to get our 4 partial products and then add them all together. Let's take a look. 3 groups of 300s. So that will be 300, 600s, 900s. So I know it's going to be 9, and it has to be in the hundreds place. Then I have 3 groups of 2 tenths. So that's going to be 2, 4, 6. But 6 what? It has to be in the tenths place. Now we're multiplying by 10. This goes back to unit 1, and I'll show you on the side here. I'm not going to do the standard algorithm for this. I'll just walk you through this on a place value chart. So I have 10 copies of, or 10 times 300ths. So remember, our place value chart, if I have 300ths and I multiply it by 10, it's just going to come over and be 3/10. All right? And then I have 10 copies of 2/10. Same thing. If I have 2/10 and I move it over one place value unit times 10, remember when we multiply by 10, we move over to the adjacent base 10 unit to the left. It's just going to become 2. Now I'm going to add all these numbers up. I'll take them all the way out to the hundreds, just so that there's no confusion when we add. Remember, I just put those placeholders in, and just zeros are just placeholders in that case. So let's go ahead and add these numbers up. So I have 6/10 or 60 hundredths plus 9 hundredths. That's equal to 69 hundredths. Then here I have 2 and 30 hundredths, or 2 and 3/10. When I add these up, I get 9 hundredths, 9/10, and 2 ones. So the snake will be, full-grown snake, once he hits his max length, he'll be 2 and 99 hundredths meters long. All right, let's go ahead and take a look at the next problem here, which is problem 4. So Zenon earns $142 per shift at his new job. During the pay period, he worked 12 shifts. What would his pay be for that period? So let's see. We have $142 per shift, and he worked 12 shifts. So right here, if I can do these multiplication problems, and you know what, I'm going to do this. I'll do this as standard algorithm and also as the tape area model. For some reason I want to call it tape diagram. All right, so let's go ahead and take a look at our area model first. I'm going to move it down a little bit so it matches up with my partial products from the standard algorithm. All right, so we know he has 100 plus 40 plus 2. And he works 10 plus 2 shifts. All right, so let's go ahead and put our lines in. Do my vertical lines first, right underneath my plus signs. And then my horizontal lines coming straight over from this plus sign here. All right, let's go ahead and do some math. I'm going to do this the fastest way possible, so pay attention to what the words I say. 2 times 2 is going to be 4. Then I have 4 times 2 is 8, and then I had 1 0 there, so that's times 10 is 80. 2 times 1 is 2. 2 zeros, so that's going to be 200, because each one is times 10 times 10. And remember, if I had 2 on my place value chart, and I multiplied it by 10, and I multiplied by 10 again, it will become 200. All right, so let's take a look here. Now I have 10 times 2. Well, I know 2 times 10 will be 20, or 2 times 1 times 10. Then I have 10 times 40. Well, I know 40 came with a 0, and then I'm going to move it over one more place value to make it 400. One more place value unit to the left on our place value chart. All right, then I have 100 times 10, which is 1 with 3 zeros, which is 1,000. Add my partial products up, 284. I get 1,420 here. So now we're going to add these two partial products up, 4 ones, 10 tens, which is equal to 100. 4 plus 100 plus 200 is 700. And then I have 1,000. So I get 1,704. Let's do the standard algorithm. And I'm going to do it the old school way, so I'm not going to say the place value units. 2 times 2, 4. 2 times 4, 8. Remember, that's really 4 in the tens, and that's really 8 tens. 2 times 1, 200. You notice these match up. 10 times 2, and next one 0, that's 2 tens. 1 times 4, or 10 times 4 tens, is 4 hundreds. And then 10 times 100, we said was 1,000. Alright, and my partial products match up again. Do the addition. We get 4 10 tens, which is 100, 7 hundreds, and 1,000. Alright, boys and girls, that is it. We are finished. Hopefully you were able to solve all of those problems on your own. Please make sure that you use this as a tool, not as a copying tool, but as a tool to check your work. As always, happy learning.